Hi people, just a video describing the indirect titration. So we've been told that the label on a bottle of a household bleach states that the minimum concentration of hypochlorite ions, ClO minus, is 5% W per V, or weight per volume. Alright, so I'm going to start coding this in some way. I'm not going to use colours, I'm just going to use shapes, but just so that I know what's going on. So every time it says bleach or something to do with the bleach, I'm going to underline it. There's bleach, and I've been told that it contains hypochlorite ions. So there we go, underline the hypochlorite ions. The concentration of hypochlorite ions is meant to be 5%. That's what it says up here, but we're actually determining that by a titration to check it. Alright. Now, in that titration, we're using sodium thiosulfate. We might circle that. Let's bring this down here while I'm doing my circling. So sodium thiosulfate. And we're using acidified potassium iodide. It's going in a square. So the steps for this procedure are shown below. Firstly, we're going to prepare a standard solution of sodium thiosulfate. Now, sodium thiosulfate's formula is Na2S2O3. So I'm just going to call it S2O32- from now on. It's a bit of a mouthful to write. Then you're going to get the bleach. Once you've prepared the standard solution of sodium thiosulfate, you're going to get the bleach and you're going to dilute it. Then you're going to mix that diluted bleach with the potassium iodide. You're going to get this reaction, bleach. So bleach was underlined, sorry. Bleach plus the iodide is going to form I2 plus Cl minus. Then we're going to titrate that with sodium thiosulfate. So here comes our sodium thiosulfate. We're going to get the I2 that has been produced and react that. And that's just down there. So we've got the I2 that was produced here. We put it into there, and we're using it to be able to work out the unknown concentration. And we've been given and told the titer value for this. Now, something that's also going to help us, we talked about this today, but is actually potentially drawing a diagram. You may find that helpful, you may not. It does depend how your brain works. But I often find it helpful to draw a diagram to sort of show what's going on. So let's draw a diagram over here. Our step number 1 was to prepare a standard solution of sodium thiosulfate. The concentration of that standard solution was 0.2034 moles per litre. That's step number 1. Step number 2 was to get the bleach. So make sure you get the right thing. New thing, bleach. We're going to get 20 mils and we're going to dilute that down to 200 mils. Step number 3, we're going to get 25 mils of diluted bleach. And we're going to mix that with an acidified potassium iodide solution where we've got an excess. And the reason we've got an excess is just so that we make sure that all of the ClO minus dissolves. And when we do that, we produce I2. Okay? Now that we've produced I2, we're going to use that I2. That's step number 4. So we're going to titrate with sodium thiosulfate. And remember, my sodium thiosulfate's a circle. So we're going to titrate with that. This is sodium thiosulfate. But that's going to go into our I2 solution. And I'm going off the page in terms of my pretty diagram. So there we go. Go up here a bit. Okay, so this is going to go into the I2. And we're going to have a reaction that occurs. And we've been told the concentration of this is equal to 0.2034, and we've also been told that the volume of that titer of S2O3- is 33.94. Alright, now the whole premise of this is that we're trying to find this. We don't know enough information to find this, but we've now been told a concentration and a volume for S2O3- Okay? So that helps, because that means we can actually now work something out about that. Once we've worked out the number of moles of that, we can work out the number of moles of this by the mole ratio. That means we've got the number of moles of this by the mole ratio because they're exactly the same, and therefore we can find the number of moles of that. So we're simply going backwards. That's the procedure. Alright, so if we look at part A now, we've been asked to calculate the mass in grams of sodium thiosulfate crystals with a molar mass of 248.18, used to prepare the standard solution in a 250 ml volumetric flask. Okay, so that's the first thing we've been asked to do. I'm just going to pull that out so we can continue to see our diagram. And I'll chuck in a bit of paper to show us what we've been asked to do. Alright, so mass of, to make up that original solution of sodium thiosulfate, S2O3, 5H2O, equals question mark. Well, to be able to solve this, we've got to think, we've been told it's in a 250 ml volumetric flask. Right, you have been told that. It's over there. It's a 250 ml volumetric flask. Okay? So that's helpful to know that it's a volumetric flask, because that enables us to be able to work with that. Alright, so if I'm going to calculate something using the volume of S2O3 2 minus is equal to 250 mils. And I've got to work out the mass. I also know the concentration. I've been given the concentration of S2O3 2 minus. We're using the standard solution. The concentration is 0.2034 moles per litre. So now that I've worked this out, that enables me, therefore, to find the number of moles. I know that N of S2O3 2 minus is equal to C times V. Now you might go, well, why did you know, how did you know to do that? Well, there wasn't anything else I could do. I've worked out, I'm going to work out the number of moles, but there really isn't anywhere else I can go from that. So I have to calculate the concentration. So if I'm doing that, I'm just going to go, well, that's going to equal 0.2034 times 0.25, because I'm putting it in litres. 0.2034 times 0.25, and that's going to give me number of moles 0.05085 moles. Now I have to find the mass, so I know that M is equal to N times M. I've conveniently in the question, if you look at it, been given the molar mass. That's going to be 0.5085 times by the molar mass, and the molar mass is 248.18. So that's going to give me a mass, which is going to be equal to 12.619953 grams. But I'm going to give that to four significant figures. So that's going to be 62 grams. If you go, why 4 significant figures? Well, if we look in the question, we've been given here 4 significant figures, here 4, here 4. So remember, we always go for the smallest amount. Alright, so that means I'm just now going to add some information into my diagram. Now I'm going to do it using a pencil, but you can use it doing a different colour. This is telling me that up here, when I've got my sodium thiosulfate solution, the mass that I used in there is going to equal 12.62 grams. Okay? Now that might come in handy later. It might not. It might just be there to give us a head start into this question. Alright. We now look at part B. We've been asked to calculate the moles of S2O3 2 minus in the average titer. So to do this question, we're going to go over to our diagram and we're going to think about it. Alright, so you have, as you know in your diagram, been given over here the S2O3 2 minus, you know the concentration and you know the volume. If you ever know the concentration and the volume, you can easily find the number of moles using N equals C times V. So we're just going to do that. So N N of S2O3 2 minus equals C times V, and that's going to equal 0.2034 times by the average titer, which is 33.94 divided by 1000. Okay, so that's going to be 0.2034 times by 33.94 divided by 1000, because we have to put it into litres, of course, and we get that that equals 6.903 times 10 to the negative 3 moles. Okay, so that's question B done. We are hopefully rolling along nicely. Then we have question C. And question C says for us to hence, I've lost my question C. Got A, B, and D. My question 3 has wandered off somewhere. But you've got it sitting in front of you, and I've got it down here. To calculate the number of moles of I2 that reacted in step 4. Alright, I'll bring that back up there. And hopefully you can see that picture. So we're being now asked to calculate the number of moles of I2. So N of I2, we're going to be asked to find N of I2. We're going to use, guess what, the mole ratio. So N of I2 over N of S2O3 2 minus is going to equal 1 over 2. So therefore, bring that up. This is just using the mole ratio and using the equation that we've got here. So therefore, N of I2 is going to equal N of S2O3 2 minus divided by 2, which is going to equal 6.903 times 10 to the negative 3 divided by 2, which will just equal 3.45168,698. Again, I'm going to 4 significant figures, so 2 times 10 to the negative 3 mole. Alright, so I'm just going to remember to add in those two pieces of information over to my diagram. I now know that the N of this, the number of moles of this, of the S2O3 2 minus, is equal to 6.903 times 10 to the negative 3. And now I've worked out up here that the N of I2 is equal to 3.452 times 10 to the negative 3. Alright, so I'm up to the final part of my calculation. The final part of my calculation is a little bit more broad. All we've been asked to do is to hence calculate the concentration in percentage weight per volume of ClO minus in the original bottle of household bleach. Alright, so when we do this, let's just write down what we've been asked to calculate first. Okay, so I've got N of original ClO minus. Now this is where I think, and I still think, that the diagrams are really helpful. Because I can look at my diagram now and go, well, what information do I have? I'm up at this step. When I've got the number of moles of I2, I've worked that out. I know that that came from when I reacted it with 25 mils of dilute bleach. Okay? And then when I took that 25 mils of dilute bleach, I then diluted that bleach. So that came from this dilution that happened here. So if I can work out what the concentration of the dilute bleach is, then I'll just be able to work out what the concentration of the actual bleach is. Alright? You've got I2, you can therefore work out the concentration of the dilute bleach, and then you'll be able to work out the concentration of the concentrated bleach. Now, how do I do that? Well, again, if I'm at this step here, and I know the number of moles of I2, I've got the volume of dilute bleach, but I have nothing else, right? So I can't really calculate anything. I need the number of moles to be able to calculate a concentration. So I can look back at here, and I've used the first equation, the second equation, but I haven't used the first. We're at this step now, we're going backwards. I2 is the number of moles of I2 is actually equal to the number of moles of ClO minus from the balanced equation. So N of ClO minus, and put this as dilute just so you remember, is going to equal N of I2. So that's going to equal what we calculated before, 3.452 times 10 to the negative 3 moles. Alright, so now I know that my dilute bleach has a concentration, has a number of moles in that dilute bleach of that. So therefore I can find the concentration of the dilute bleach. That's going to equal N over V, which is going to be 3.452 times 10 to the negative 3. And I know the volume because I've been told it's up here, right? 25 mils. So divided by 25 divided by 1,000. So that's going to equal, if I divide that by 25 divided by 1,000, that's going to equal 0.138067 moles per litre. Now that's still the dilute bleach, right? So we're not there yet, we're almost there. We've just got to calculate the concentration. Remember, we're aiming for the concentration in the original bottle of household bleach. So we first need to find the concentration of the original bleach. That's what we're looking for, remember? And we're going to use, we know we've had a dilution, so we're going to use C1V1 equals C2V2. We're now looking for C1. The C1 is going to equal C2V2 divided by V1. Now if we think about what we've got written here now, we've got this dilute bleach, which is right here in my diagram. This dilute bleach has a concentration of 0.1381 or something. Right, that's its concentration. So we know what C2 is. We know that the volume that we have C2 in is 200 mils. We know that that comes from a volume of 20 mils, so that's our V1. And so therefore we can find C1. So C1 is going to equal 0.1381 times by our volume of, which is 200 mils, but I'm going to put that in litres, so I'm going to put the 0.2, divided by our V1, which is 0.02 because it's 20 mils. And that's going to tell me my concentration. So my concentration, my original concentration, is actually going to be 1.380672 moles per litre. Now I've been asked to find the percentage weight per volume. Alright, so if I look therefore to find the percentage weight per volume, I just need to convert that one into grams per litre, and I do that by timesing by the molar mass. So that's going to equal 1.381 times 51.45 grams per litre, and that's just by timesing by the molar mass, which is on your conversion chart if you're wondering where this is coming from. And so that is going to give me, once I do that, times by 51.45, it's going to give me 71.035 grams per litre, 359. So then to put that into percentage weight per volume, I simply need to divide that by 10. So it's going to give me 7.10, and then I have to put four significant figures, 0.04 grams per 100 mil, which equals 7.104 percentage weight per volume. Done. Alright, there's our titration. There's our diagram. Pretty diagram. Hopefully you can draw better than me. And there's our working out for that last bit. Hope that makes sense. Go back and rewatch anything that doesn't. Good job, people.